Okay, let's get started. And thank you all for coming today. And did you guys have a good break? Okay. So I want to ask some questions before we start. Like, how many problems? Like, okay, how many of you solved like 25 tree problems on LeetCode?
After coming to this.
Yeah. Second question. Or okay, even in general.
I don't know, like after coming to this class,
Okay, like really, like you guys are taking the time to come to this class, and the point of this class is that you guys get offers for internships or full-time, right? And like just attending this class is not gonna like amount to much if you don't work on your own. So like really take the time to like solve these problems. I can't emphasize that more. Like I would love to see like you guys get placed, because they'll also like speak well about me, right? And my students got placed, so please solve those problems. Yeah, I'm gonna like keep repeating this every class, but that's because it's really important. Okay, let's move on. We're already like pretty late today. Okay, so how many of you were here last class for the trees? Okay, so we were doing binary trees, and like some of the time I'll refer to like something we did in the last class. It's okay if you don't like follow that. The videos are up, so you guys can like check that out later. Okay. Okay. So okay, this title is kind of misleading. I kind of like came to this title in the beginning, and then I put these problems, and then it feels like this wasn't describing them well enough. So I'll explain what this category is about. So let's look at these problems first. Okay. Okay, I think this is too big. Hang on. So does everybody get the problem? Yeah, even if you don't get it, I'll explain what it is. So this is an example. Do they have, yeah. So basically they give you a tree, and every tree has some left nodes on the left and some nodes on the right, right? So for each node, I can compute the difference between sum of all the left nodes and sum of all the right nodes. Okay, that is the tilt of that node. Because like tilt means like something is like bigger on one side and smaller on another side, right? That's when things get tilted, right? So each node has a tilt associated with it. So you're supposed to compute the tilt of all the nodes in the tree. So what is like the first like brute force idea that you guys get? Yeah, recursion, but elaborate more.
left to right,
Yeah.
and then
Yeah, basically I go through every node, and at each node I can call two helpers that compute the sum of the left subtree and the sum of the right subtree, and I can compute the difference, and I can output that difference. And at each node I get the difference of this guy and this guy, and I get the difference of this guy, and then I add them all together. You get it? But what would be the runtime of that?
Walking?
No.
What are you doing? Because
Yeah, so how I'm doing it is, let's say I have this tree. Okay, this doesn't have to be a BSD, so this could be anything like 8, 4, 6, 3, 3, 9, 7. Okay, so at this node, I want to know the tilt of this node, and I also want to know the tilt of this whole tree, and the tilt of this whole tree. Then the final answer will be sum of these two tilts plus the tilt at this node.
That's correct.
Right? So that's the brute force way, right?
I didn't get the brute force.
Yeah, so basically you want, so there's two tilts. There's tilt at each node, and there's the tilt of the whole tree. So the tilt at each node is just the difference of the sum of all the nodes on the left and the sum of all nodes on the right. That's the tilt at that node. So for 8, the tilt would be 13 minus 19. So it would be, it's right minus left, right?
Absolute difference.
Okay, yeah, nice. So for 8, it would be 13 minus 9 is 6, right? So for 8, it would be 6. For 4, it would be 3. 6 minus 3. Here, it would be 0, 0. For 3, it would be 2, 0, 0. So the final answer should be sum of all these tilts. That's what they want you to output. Okay? So right now, like when I'm writing my function, I'm looking at each node individually, right? So my function should output the tilt of the whole tree rooted at that node, right? So that means the tilt of just that node alone, plus the tree tilts of the left tree and the right tree, the complete tilts, right? And I get that by calling the tilts of the entire left and right trees. I can get that by calling the function recursively on left and right. And I have another function that just calculates the sum and just gets the tilt at this node. So basically, I have a function f root, and I call it on root.left. I call it on root.right, right? And those are this 3 and 2. Okay, then I have another function f1, which calculates the sum of the entire tree rooted at 4, and the same function f1 that calculates the sum of all the nodes rooted at 3, and it just outputs that. So that would be 3 and 2. So from here I get, so let's do root.left and root.right again. And so this guy would give me, left is 3. This guy would give me 2. Well, what would f1 give? Sum, right? So that's 13. And this guy would give me 19, right? And then I do like a constant time operation with those guys. So what's the runtime if I do this? In squared. Why is it in squared?
You have to do it in twice.
Yeah, for each node, and doing O of n operation. So here I do O of n, here I do O of n. I mean, n meaning all the nodes rooted at that node, but depending on how your tree is built, that could be n, right? Worst case. So this is O n squared, right? That's just like very simple post order order, so you're not using any fancy or clever ideas. So this category of problems is like, the strategy is about how you would solve problems where you're supposed to do something at every node. Like, not all 3 problems involve doing something at every node. We'll look at the next category where you should not do something at every node. You should do things only at like specific nodes. So, but there will be problems where they say binary tree tilt, which is sum of the tilts of all the nodes, right? So for those problems, it's always best to have a global variable that is accumulating that value at that node. So yeah, so you
So we should be able to compute everything in the world.
Yeah.
Sum, tilt.
yeah. So at each node, you make like a constant time computation and update that global variable, right? Okay, let's look at how to do this in O of n. Actually, I'm not quite confident that this can be done in the OAuth end. Actually, it can, yeah. Oh. Come on, I logged in. Okay, 1 second. Yeah. Okay, hang on. Let me zoom it in.
Oh, you're returning to someone.
Yeah, so I'm not doing like a regular post order traversal. I'm using a helper function, tree sum, which basically returns the sum of all nodes rooted at that tree. Okay, and I get all the nodes of the left and the right, and I just update this, and then I return the new sum. So how is this different from the post order traversal? What are we doing?
So
How did we get an advantage?
Sum every time basically.
Yeah, in post order, what did we do?
So we are calculating the sum separately and
Mhm.
a separate recursion, treat the separate recursion.
Yeah, we had a helper function to go through all the nodes to calculate the sum. And then we use this function recursively, right? But you can use a helper, you can use a global variable, and you can do this. So you guys would have noticed that the global variable is not like the key,
Last.
is not what like really characterizes these problems, but it kind of like is in the picture and it helps partially. So yeah, so I can't come up with a good name right now for this category, but you guys get the gist, right? Yeah. So yeah, like just basically use a helper, like already. That's the takeaway. Is this good or does any of you have?
Whenever we need to return more than one items, we will go for like declining the class level way. Right?
Yeah, and in some cases, like in this case, it's very tempting to use that idea, but if you like, in some cases it will so happen that you won't need two things. You can like capture all the information of those two things in just one. Like the problem we saw like last 2 weeks ago, where you were supposed to return the ancestor, like the least common ancestor. There, I mean, I don't want to go into that right now, but you can like cleverly plug the information captured in two variables into one, and then just have a function that will return that. Okay. Okay. No questions, right? I can move on? Okay. Okay. Okay, so this kind of is a test for like how much attention you guys paid in the last class. Why did I say that?
Because we had this.
Yeah. And how did we solve it?
We had a custom class to compute more.
Okay, first of all, sorry to interrupt. Does everybody get the problem? So the diameter is just the longest path between any two nodes in the tree. So for this tree, does somebody want to tell me which nodes have the longest path to get from one to the other? Yeah. From here to here, right? And it does not have to be the case that given a tree, the longest path passes through the root, right? Because this whole thing could be rooted at some other node, and the diameter would still be that. Could be this as well. Okay, so this is a bad example, but just saying. Can you guys like conceive of a tree where the root itself does not have? So I can have a root, and I can have like a long tree
Yeah.
where the diameter. So I can have something like this, So I can have 10 and I can have, actually the value in the nodes is not important. Okay, so the diameter for this tree is between these two nodes, this path, right? So it'll be 6, right? And the longest path does not pass through the root, right? So last class how we solved it is we used post order, but the return type for my post order was a custom object that would return two things. What would it return?
Diameter and depth.
Yeah, so it would basically return for every node, so I could have like other nodes here. So for every node, I will get two things.
The longest.
Yeah,
And the diameter.
yes, so the first thing was D, which is the diameter of the tree rooted at this node. And the second thing was the depth. That means just the longest path starting from root to leaf on this tree. So everybody understand what's the depth of a tree, right? It's the longest path between the root of the tree and one of the leaves, right? So for this tree, it would just be this guy. So I would return 3. So yeah, for this guy, I would return I would return 6 and 3. And what would I return for this guy? What's the diameter and the depth? What's the diameter and the depth?
How did we calculate diameter?
Yeah, so the definition of the diameter is the longest distance between any two nodes in the tree.
8 and
No,
10 you are talking about?
no, I'm talking about the right subtree. So just tell me.
Depth would be 2 and diameter would be 3.
Yeah. Does this make sense to everybody?
If you're including the node itself, then yeah, you can add one more.
So the diameter is 1, 2, 3, this guy. And the depth is 1, 2, this guy. So again, the definitions are the longest distance between any two nodes in the tree. The depth is the longest path from the root of the tree to one of the leaves of the tree. Right? So that's how we did it last class. But if you, yeah, somebody had a question. Okay. But like the strategy that I'm discussing today is, what is it? Like how did I calculate
It's
it?
a class tree.
Global
Class
distribution.
Yeah, that's like a misnomer. I actually put that in there, but that's wrong. The actual definition is, I don't have a name for it, but the definition is you do something on every node.
Use across the methods. It's a class tree. Something.
Yeah,
Class level way.
yeah. You have a global variable, and then you do something for every node, and you update that global variable's value for every node, right? So here, if I want to calculate the diameter, what can anybody think about the one thing that I'm doing at each node?
Calculate the depth.
Yeah. So the maximum diameter will be at some node, it will just be the sum of the depths of the left and right subtrees, right? So for no matter what the diameter is, between those two nodes, I can find like a common node, the highest common node. And at that, with that node as the root, I would have only calculated the left depth and right depth and summed them up. And that would be my diameter. So if I just did that thing at each node, I would end up with the longest diameter, right? So this way, you're writing more code, but it's easy to come up with a solution.
But once you are update,
Yeah,
then that won't be a walk-in solution, right?
it will be an often solution because
You are not saving that length of the longest depth till that node anywhere.
the length of the longest depth till
Like
that
the
node.
depth.
I don't need the longest depth till that node. I return that value. I have a helper function that just returns the longest depth at each node.
Yeah, but that would be again a walk in runtime, right? At each,
No.
at each node.
So if I know the depths of my left and right subtrees, then what is the current depth?
Suppose right now, let's take the first level node, and the depth would
10,
be
right? You mean 10
no,
or-
the second, that's 0, yeah.
Okay.
So now you know that the depth over here would be 3.
Yeah. The
right?
depth over here is also 3.
Yeah, so what you have written back from here now?
You tell me. So if I have the left
What
depth and the
here?
right depth, what is the depth of the whole tree?
3, right? So which is the highest basically. No, he's not
No,
diagonal.
no, one second, one second.
He's not diagonal.
So if I have, so yeah, right now there's two things. There's depth and then there's diameter. Okay? Diameter is what you're supposed to output out of the main function. Okay? But we just broke the diameter into two things.
Extent, right? Yeah.
The diameter is nothing but the sum of the left and right depths. Right? So if I have a function that just returns a tree's depth, I can use that.
Yeah.
And at each node, I can calculate like it's the diameter rooted at that node.
So you're calculating, suppose now
Yeah.
you do recursion, right?
Yeah.
Let's say you are the second level node,
This one.
one more level down.
Okay.
You calculate the depth over there, that's 2.
Yeah.
You go back up.
Yeah.
So are you going to take the already previously calculated depth, or
Yeah.
are you going to calculate freshly again from that node?
No, I'm gonna use the.
Helper function.
No, it will always be
So
a
I have-
depth of left plus 1.
I have one function that will give me the depth. Okay. One second.
No, so my question is, so
Yeah.
you're going to call the function for every node?
Yeah.
That
I'll
would be
call that
equal to
function.
n square, right?
No, it won't. That's what I'm saying. So that function itself will just return the depth.
Maybe you can.
I can show you the code.
Yeah.
Yeah.
Not good.
Can we see the last week's solution as well?
Yeah. Good idea.
Last
Yeah.
week is off in the class, but I don't see this one.
Yeah. Okay. Let's. So I got an idea today when I was thinking about how to like compare, like how to view the solution alongside the problem. So I can take like a snip of the code and put it there. Put it on Paint. Okay, one second. Okay, let me draw it again. So let's just say I have a tree like this. Okay, for this problem, I don't care for the values, right? Okay, let me do more. Okay, let's say I have a tree like this, and that's my solution. I'll show the last week's solution after this, but this is what I'm proposing right now. So I have one function that will give me the max depth rooted at a tree. So what is the max depth rooted at this node? 2.
Either left or so this comparison will be left or right.
Yeah, no, but what will be the output when I call that function on this node? 2, right? Or no, it will actually be 3 because for now I'm returning 0. If I just have a leaf, it will return 1. I just have one node, it will return 1. Okay, so do you get it now?
Yeah.
Do you get it why it's so often?
No, I was the diamond part of it, so you use a global variable, right?
Yeah.
That's where it became off. Yeah.
Yeah, so that's where the global variable comes. So basically there are 2 pieces of data involved here, and one of them is the return type of the function and the other one is a global variable. So I don't have to do the returning the custom object, right? So, and yeah, to like follow this approach, you have to come up with an idea of what you need to do at each node, right? To calculate the diameter at each node, all I need to do is get the max depth of the left and right, because the diameter eventually will have some node as the root. Right here, the diameter is actually this guy, right? So this is the root. So I would have captured that diameter when I'm looking at this node. The diameter for this guy will be again here, and then I would capture that here. So eventually I'll be at a node which will tell me what is the max like diameter thing of that tree, of that whole tree, right? So and the diameter is basically left depth plus right depth. Because I'll be returning 1 for leaves. So if I'm here, this would give me 2, right? That means 1, 2. And this would give me 2, 1, 2. And then I just sum them up. Make sense?
Okay, either we will be doing that +1. I mean, if we do +1 in diameter, then we would have to check off like root dot left and right both are null. Then we would have. Is that correct? I mean,
You're
if
talking about the
we-
leaf?
Yeah, if for leaf, if I want to return the depth as 0.
Yeah, so that's another good point that she brought up. So she's asking about, so for some tree problems you can get away with writing one base case. For some tree problems you have to write a separate base case for a half leaf and a leaf, right? So this, so how you judge that is you definitely have to have a base case for a half leaf, and sometimes that also works for a leaf in this case. That's true in this case, right? Because for a half leaf, if the root, so a half leaf is this guy, where one of them is null, right? So if I'm looking at this guy, this will return 1. What will the output of this guy return? I'm asking.
Oh, I
What will the output of this guy return? Like I'm looking at this leaf, sorry, this node, and this will return 1, right? And this will return 0. And I have to have this code to handle like this case, right? Yeah.
Single case is handling like everything.
Yeah, and it so happens that here, even for the leaves, I get the output that I desire, but just by thinking that case, right? In that case, you just want to write.
No,
only one,
I was
but
thinking
yeah.
to, in case of definition,
Yeah,
what is actually depth of a leaf? It's 0.
yeah, that's true. Yeah,
So
so
here we are making it 1.
yeah, here I'm making 1 because if you want to make the depth of a leaf as 0, then what do you put for null case?
It will be like root left and right, and both are null, then it returns
0. But what will you do for just root equals null? What will you return there? No, you have to have something, right?
We will not face it, right?
Right,
If
for
we
half
check for
leaf, you
left
get,
and right.
yeah, so that's a full leaf. So you that alone
I
will
mean,
not
if
suffice.
both left and right are
Being
null.
null. Yeah, that will only handle something like this. But if I'm here, I look at left and right, so I will get to a case where root is also null.
Yeah,
Makes
but
sense.
we have to come inside and check the left depth for this particular half leaf. So
No.
if both are not null, if both, I mean either of them is not null, then again before going inside left or right,
Yeah,
you just
so you have to-
make a check.
So you have 2 checks. One is to see if both are null,
Yeah.
and another one to see.
Either of them, whether either of them is
Yeah, that's also I think redundant. You can just have this.
okay.
Because if either of them is null, yeah, you only handle. Yeah, if either of them is null, you have to write all this code only for one of the branches,
Yeah.
right? That's too much code because you have to know which of them is null, and you have to call this function representative on that one. If left, so that clause will be true if either right or left is null, right? In that case, you need to know which. You might
we-
decide between,
I
yeah,
thought
right,
like
more.
just put a if condition for left separately and right separately
Yeah,
before
that's
going.
true. Yeah, you can do that as well. Yeah, that will work.
It will be like 3 if instead of a single.
Yeah, and I'm guessing that this math will be different in that case,
Huh.
right? Yeah, I just chose this for convenience,
Okay.
but we are definitely deviating from the actual definition of like a depth. Right? Yeah, you can do that too. That will be more code. Actually, I like that because you want to like always make your code more readable. So if somebody else is reading, they already have this notion of depth, what is depth,
Yeah.
and you don't want to force them to like follow your notion of depth. Okay, we can run this algorithm on the street to see what we get. So I start here, and yeah, so I'm not doing any work in this function, so I immediately enter this function with the root. Okay, so what happens after that? I run this line.
Yeah, it's not.
Yeah, it's not going to go in. So I call this guy now, right? So it goes here, and again this guy, it goes here, it comes here, and what does this guy return? Yeah, this guy returns 1 because it gets 0 and 0 from here, right? And you just return 1 plus max of 0 and 0, which is 1. So this guy returns 1. And now this guy's right returns what? This guy does not have a right. So what does it return? Oh, sorry. Return 0. It returns 0. So this guy gets executed. So I have 1 and 0, and I update the new diameter to be 1 plus 0. So right at this point the diameter becomes 1. Right? And what do I return?
2.
Yeah, you return 2 because left is 1, right is 0, 1 plus that. So you return 2. And from here you do a similar calculation to return 2. And at this point you update the diameter to be what?
I mean, 2 plus. That be 3. That be right.
Why will it be 3? What I'm asking about what the diameter will be.
Diameter at which node?
At this node.
This node. So it's left plus right.
Which is
4.
4 because 1, 2, 3, 4. So yeah, at this node the diameter would have become 4. Okay, and what does this guy return?
5.
3, yep, right.
No.
Second side.
Oh, max. Sorry. It's 3.
It's 3 because the return type is the
That
depth.
will be a confusing diagram.
Yeah, I know. So the return type will be 3. And here, well, I mean I can go through it, but it's trivial, right?
Okay.
So what will be the return type here?
Depth of it
Yeah,
is 3.
yeah. 3 because I'm just looking at the depth. 1, 2, 3. Yeah. And I update the diameter to be 6. And at anywhere in the tree, I would not have gotten anything more than 4 because the max here is 3 alone. So at this point, this function exits, and I would have just updated this value, and I just return that. Does this make sense? I see some of you are blank. I don't know how to fix that. You have to let some
Maybe
of
at
you get
each
it.
level we should write diameter is this, depth is this. Then it will be.
Yeah, but like, yeah, I can do that, but that will be like 2 months. I can do that for one problem, like in a whole category. That's what we'll do. So I'll be solving one problem. So we will be doing that like really deeply. Okay? Okay, let's go ahead and solve the next problem.